There we go. Okay, so for this lab, basically what we're going to do is we're going to have a variable voltage source, right? And we're going to have an ammeter. The ammeter is going to measure the current flowing through, and then we're going to have a voltmeter like this, and we're going to hook this thing up to a light bulb, right? And so we should be able to measure simultaneously the current flowing through the light bulb and the voltage across the light bulb. Yeah? Ultimately, we can figure out the resistance. The resistance of this guy is going to be V over I. And if it is ohmic, if it is an ohmic device, okay, if we make a graph of current, in this case we're changing the voltage and manipulating the voltage and measuring the current, right? So we're going to make kind of an inverse graph here. When we graph it this way, if it's ohmic, what should the graph look like? If it obeys Ohm's law, what should that graph look like? Well, I is equal to V times 1 over R plus 0. Yes? Y equals mx plus v. What's that? What does that look like? It's just a straight line, isn't it? If this obeys Ohm's law, it's going to be this beautiful straight line, and it'll go this way too, right? Okay. Now, to the extent that it doesn't do that, then it's not an ohmic material. So really, this applies to pieces of wire, and not a whole lot else. Carbon, semiconductors, things like that act sometimes differently from this, right? And so we're going to do, how about what if the piece of wire gets hot? What's going to happen to the resistance? Yeah, it should go up, right? Okay, so if the piece of wire gets really hot, and of course the light bulbs get dramatically hot. They get so hot that they glow white hot. Yeah? Okay. Yeah, there we go, right? And so I'm predicting that the resistance is going to increase. Now, this is tricky because what does it look like if it's a low resistance? What does low resistance look like? Well, for a given voltage, what can you say about the current? If it's low resistance, what's true? It's a lot of current, yes? Right? So low resistance, if it's like this is actually low resistance. If it's like this, it's actually high resistance, right? So remember that the slope of this graph is actually 1 over R, and that's something we're going to have to use in our little graphing pre-lab. Once we find the slope, which is how grown-ups would find the resistance, right? Once you find the slope of that, 1 over that slope is the resistance, okay? So what we think is going to happen with the light bulb is when it's cold, it's going to be low resistance, and when it's hot, it's going to be high resistance. So it's going to go from this slope to this slope. What's that going to look like? Yeah, it's going to kind of do this, right? Okay, and it's very beautiful. It's very beautiful. For this lab, I just give you the voltage ranges I want you to use because it happens in a really narrow voltage range, but it is a beautiful thing. So when you get to the lab, you'll just see the voltages that you should try, and just try those and measure the current, okay? And then the other clue I'll give you is that it's very hard to get the voltage to be exactly a thing, right? So sometimes kids sit there and it's like I say try 0.02 volts, and they sit there for like 5 hours trying to get exactly 0.02 volts. Well, isn't it okay to get 0.019? Yeah, that's okay. It's close to 0.02. Just write down 0.019 and write down what the current really is, okay? So don't spend a lot of time, but just get in that neighborhood. And the reason I do that is just that the actual change in resistance happens in a narrow range, and I want you to see it. So that's cool, right? How about a diode? Diodes are weird things, okay? So you're going to try a diode, and what a diode does, by the way, is not much happens for a little bit, and then suddenly it just opens up. It's like a switch. It turns on, right? It's a very cool thing, right? And so it sits there and goes no current, no current, no current. And at about 0.6 volts, it's going to shoot straight up. And so be careful. Okay, keep your eye on the ammeter for that one, right? At about 1 amp, you better stop because you're going to burn up my diode. Okay, and it goes from 0 to 1 amp in a very narrow range of voltage. So just watch that, right? In the other direction, nothing happens, no how, for a long way. And then, by the way, if you find the end of that, the diode turns into a little puff of smoke, right? So don't go beyond like 10 volts. Yeah, looking the other way, right? So diodes are kind of a one-way thing. I'm taking kind of all the joy and wonder out of the lab, but I also don't want to destroy my diodes there. And so make 3 nice I versus V graphs. Okay, you're only going to make 2. Change that 3 to 2. There's only 2 to make, right? Answer these 3 questions. There's only 2 questions. Apparently there were 3, but now there's only 2, right? So change that, answer these 3 questions to 2. And then just be sure that when you're answering those things that you cite data refer to specific regions to the graph to back up what you say. Yeah. Questions? Yes, sir. Oh, yeah. Yeah, you can. Did you get also the graphing pre-lab and the? I did not. And a piece of graph paper. Did you get the pre-quiz? No. Oh man, look at you. It's your lucky day. There's all of those. All right.